welcome back. Now we come to a problem I'm calling damping constant and intensity of plane sound wave. We are introduced to the concept of a damping constant here. When a sound wave travels through air, there's two reasons why the intensity can drop. One, if it's a spherical sound wave, it will spread over a spherical area and its intensity will drop because it's going to cover a bigger area, okay? But besides that, there's some damping that happens while it's moving through air, and the air absorbs some of the intensity of that wave. The sound wave begins to get less and less louder, right? For a plane sound wave, the equation is like this. Y of x of t is a e to the minus gamma x. Gamma is the damping constant of the medium, of the air, right? So notice what's happening. The amplitude of the wave is decreasing as x increases. So when x equals to 0, the amplitude of the wave is equal to a. So this can be considered the effective amplitude of the wave, a prime, e to the minus gamma x. When x equals to 0, the amplitude of the wave is a, right? But then as the wave is progressing in the x direction, the amplitude is dropping exponentially. So it's going to be, the intensity is going to drop, right, over time, and eventually it's going to be inaudible, right? So then let's say it says, assume the damping constant is 0.025. The units of the damping constant is meter inverse, okay? So then let's say, assume that the intensity is 70 decibels, right? When x equals to 5 meters, what will the decibels be? What will its intensity in units of decibels be when you reach 10 meters, if you double the distance, right? Now, theoretically, for a plane wave, if there is no damping, if there's no damping in the air, the amplitude can potentially just last forever and be equal to a. So if there was no damping due to the air, it will always be 70 decibels, okay? Because this is not a spherical sound wave. We're assuming that the progression of the sound wave is a plane sound wave, so it's only in one direction, okay? It's a one-directional sound wave, so it doesn't spread over a surface area. The only reason there's damping is because of the damping constant due to the air, okay? So how do we solve something like this? Well, the intensity of a wave is proportional to the amplitude squared of the wave. Remember the equation for power is equal to half amplitude squared, frequency squared times velocity of the wave. So, of course, in this case, we're not changing the velocity, we're not changing the frequency. The only thing that's changing as x gets bigger and bigger is equal to the only thing that's changing is the amplitude, right? So notice that the power and therefore the intensity of a wave is proportional to its amplitude squared. Okay, so we're going to say here intensity is proportional to amplitude squared. Okay, then the decibel scale is the log of that. So what we could do is something like this. We can say here the intensity I1 is equal to so we can say here the intensity I1 is proportional to the amplitude squared, right? The amplitude when x equals to 5, right? It's going to be a e to the minus, and then you're going to put here 5 gamma, right? So then the intensity is equal to the amplitude squared. So we're going to then square this, right? And then we're going to say that's equal to a squared e to the minus 10 gamma, right? So that's the intensity at x equals to 5 meters. What's going to be the intensity at x equals to 10 meters? So we say I2 is proportional to a e to the minus 10 gamma squared. Okay? So then that's equal to what? A squared e to the minus 20 gamma. Okay? So the only difference is that when you're doubling the distance, this is going from e to the negative 10 gamma to e to the minus 20 gamma, right? So then, what are we going to do? Then we're going to say the intensity in decibels, 70 decibels is equal to 10 log of I1 over I0. The I0 is the threshold of hearing. That's when you don't hear anymore, right? Then that's given as 70 for when you are at 5 meters, right? The intensity, we don't know what it is. 10 log of I2 over I0, right? So this is the value that we want to find out. We can call that B2 for decibels, right? dB2, let's call that. We don't subtract this because this value I expect it to be less decibels, right? Maybe it's going to be, instead of 70, it's going to be 60 or 50. So I expect this number to be less, so I can subtract these. And how do I combine that? Well, I know that when you take logs and you combine them, what I can do is I can say this is plus, and I can invert this, right? And I can say I0 over I2, right? Then I can say, factor out the 10, and then log of A plus log of B is equal to log of A times B, right? So then I have here 70 minus dB2, 10 log of, then just say I1 over I0 times I0 over I2. Then I0 cancels. So then you just basically have 70 minus dB2 is equal to 10 log of I1 over I2. Okay? I1 is going to be A squared e to the minus 10 gamma. Right? So let's write that here now. 70 minus dB2, 10 log of, okay, so I1 is going to be this one, A squared e to the minus 10 gamma divided by A squared e to the minus 20 gamma. Okay, so then we don't even have to know what the amplitude A is, right? The A squares cancel. So then you get here what? 70 minus dB2 is equal to 10 log of, okay, then you get here e to the 20, the e to the minus 20 gamma goes to the top. So then you have here e to the 20 gamma minus 10 gamma, which is going to be, that's going to be 10 gamma, right? So log base E is going to be a certain number. It's not going to be 1. So the 10 gamma is going to come out to the front, right? Then you're going to have here 70 minus dB2. Then the 10 gamma comes to the front, makes this 100 gamma, right? So then it's going to be log of E. Log of E. So then I can put down what the gamma value is, 0.025. So then you have here 70 minus dB2, 100 times 0.025, that's going to be, the 0 goes 2 places to the right, so that's going to be 2.5 log of E. Then we can calculate what the dB2 is, right? So that's going to be 68.9 decibels. So when we went from 5 meters to 10 meters, now if there was no damping in the air, it would have stayed 70 decibels, right? But when you go from 5 to 10 meters, it drops and it goes from 70 decibels to 68.9 decibels, right? Now if we had gone from 5 meters to, let's say, 20 meters, what would have happened? 5 meters to 20 meters, right? What would have happened? Well, instead of 5 gamma here, this would have been 5 gamma, this would have been here 20 gamma, right? 20 gamma. So then if you square that, this becomes 10 gamma, this becomes 40. You see? So it starts multiplying, right? So then when you put the 40 here, right? And then when you put 40 here, then the 40 goes up and makes this e to the 30 gamma, right? 30. And then you get over here, the 30 comes down, makes this 300. Right? And then 300 times 0.025, that makes this 7.5. So then at 20 meters, how many decibels is it? 66.7 decibels. So it drops another about 2 decibels. You see there? From 5 to 10, it didn't drop a lot. It dropped like maybe 1.1 decibels. Then it drops 2 decibels. Now, when is this sound wave going to be inaudible? Well, it's going to be inaudible when you finally reach 0 decibels, right? In other words, when dB2 is 0. Okay, so how do we calculate that? Well, what you can do is put here x, some general x value, right? And then, well, you're going to get what here? Then you're going to get here e to the minus 2xy, right? The top, you're still going to have e to the minus 10 gamma, right? So then you're going to have here e to the minus 2x gamma, okay? And then when you combine these, you're going to get here what? This one will go up to the top, and you're going to get 2x minus 10 gamma, right? Then that's going to multiply there. So then let's see what we're going to get. You're going to get here 70 minus dB2. You're going to get 10. Then the 2x minus 10 is going to go to the front. 2x minus 10. And then gamma. Then you're going to have log of e, right? And then gamma was 0.025. So multiplied by 10, you're going to get 0.25. So 70 minus, and then dB2 is 0. Because when the decibels is 0, it's finally inaudible. So you just basically have 70 here. And then you have here 10. So then you have here 10 times gamma was 0.25. Right? Then you have here 2x minus 10 log of e. Okay, so the way to solve that, you divide 70 by 0.25, which is basically like saying 70 times 4. So you would have to go very, very far out for that plane sound wave to be so absorbed, so damped by the atmosphere and the air that it is basically inaudible to you, right? So 327.4 meters out, that sound wave will be completely inaudible, okay? So the next I will do a spherical sound wave, which spreads out spherically. And so there's two things that will cause its intensity to drop. One is the fact that it's spreading out spherically. Then plus I'll add a damping constant to it. So then that will also cause it to for its intensity to drop. Okay? Thank you very much.